Can I do this? For the material you've been going over, were you able to get through um the rest? Sorry, you already did your fluids. Were you able to get through electromagnetism?
Mhm.
Awesome.
I just I got to all the way to trying to look at it now. I got all the way to waves and
And sound.
like I just touched on waves and sound. Yeah, got the
Okay.
definition stuff.
Sweet. Okay. Awesome. So let's go over. Oh, excuse me. Let's go over some physics. All right. I'm going to share my screen with you. All right. Can you see this okay? Or do I need to zoom in or something?
You're good.
Okay. So what I want to do today is practice going over a passage. I'm going to talk to you about kind of how I like to break down passages and then how I like to go through the questions, and then we can discuss how to and then I want you to kind of practice and have you go through it while we while we're together here. Um how I want to know, how do you go through an MCAT passage? What is your algorithm? What's your process?
Okay, so before when I was studying with Jack Weston, I would write down as I read the topics that came up. I did it for like
You would write down the topics?
no, not the topics, but like I'd write down like little things as like I went. Like for instance, I think this has gotten to do with cardiac. So like I'd write down a pathway, so to say, for my sciences because it would all link and then go into the questions. Sometimes it would come with like sometimes I would know what the topic is, so I would know what equation to use or have written down. And sometimes I wouldn't know like, specifically what it's using, or I would pick the wrong equation, so to say.
Okay. Okay. I think that's awesome. So when you're going through and you see something that has to do with, I don't know, like force, you write down, okay, F equals ma. All right, let's move on. And then you keep going through, and then they give you some information about maybe like friction. So you write down the equation that has to do with friction. And okay, sweet, sweet, sweet. D- excuse me. Do you ever use the highlight feature?
Okay, so then towards the end, because I was like, I'm taking too long writing because my top problem is speed, I decided to use highlight feature
Okay.
instead. So now I've transitioned into highlight feature, just highlighting. And when I highlight, I'd either highlight, I wouldn't highlight whole sentences. I'd highlight keywords. For
Mm,
instance, like, it's easier for me to highlight in the bio. Um,
okay.
but for like chem and phys, like I'd highlight density of blood and density of water, that stuff, or um what the topic is about. Like what are we doing? We're dealing with buffalo, so I do that. So I don't know. But for bio, it'd be like I'd highlight what the experiment is and um the different factors of the experiment that they want me to know about, and then anything that has to do with the result if it's not. the result if it's not what's it called it graph or something like that.
Okay. All right. So when I'm going through a physics passage, for example, I like to do something similar with the highlight feature. I like to highlight stuff that will help me to recall that information when I'm going through the questions, or information that I find to be particularly significant that I would like to come back to if I need to reference it. Um, I, as far as like taking notes, I think making passage maps is really, really helpful, but it can take time. So particularly when you have like a biology passage or biochemistry passage, those are really good for passage mapping. Physics passages tend to be a little bit more difficult to passage map, and chemistry passages similarly. But it just all depends on how people do with speed. So since you mentioned that you typically have had a bigger struggle with your speed getting through the passage, I think that we could probably utilize the highlight feature more. But also I think that using kind of a talk back method might be helpful. For example, when you're going through the passage and you're reading it to yourself, um, rephrase what you're reading
Okay.
so that you can understand it more clearly, and then the next sentence comes along and you can connect that to the previous sentence a little bit more easily. Um, so for this passage, what I'd like to do is go through and um, I want to, I want you to be reading this passage, but I want you to read it out loud and talk to me through your thought process. Explain to me what your what's going through your head when you go through the sentence. Um, how are you how are you understanding it? What would you say is important? What would you highlight, etc. Does that sound good?
Hmm. Yes, it does sound good, but let me put my headphones in.
Okay.
Hello.
Hello.
Mm. Headphone isn't working. Okay. Mm. Can you hear me?
Yes.
Okay. The heart alternates between phases of systole and diastole during just basically heart phases. During diastole, cardiac muscles relaxes, outflow valve closes, and blood passively fills the heart. So we're talking about blood pressure and how blood flows during systole. Cardiac muscle contracts, blood outflow opens, valves open, and blood is actively ejected by the left ventricle into the aorta and into systemic circulation. So for diastole, the it's passive, but systole it ejects, and diastole is closed and systole is open. The valves. The physiological driver of systemic blood flow is thus a pressure gradient between the high pressures generated by the left ventricle and the aorta relative to the low pressures found in the veins, returning blood to the heart. I feel like we talked about this topic. of fluids and like yeah. When modeling blood flow in the circulatory system, blood flow can be assumed to act similarly to water. Then we have the density of blood and the density of what's it called? Water. The density is I'm gonna round that to 1,000. And
Salud.
thank you. M over V. Oh, I thought I could scroll. Yeah, circulatory system. Mean arterial pressure is often measured at the brachial artery located in the upper arm. It is calculated as the sum of the pressure of deeply plus 1/3 the difference in pressure during systole and diastole. MAP is also equal to the product of cardiac output, the flow rate through circulation, and systemic vascular resistance. We did something like that. It is important to consider how vessel type contributes to the pressure gradient. So this is telling us to think about pressure gradient each vessel type. The arterioles are responsible for the greatest drop in pressure, despite their small size. So I'd highlight stuff like despite and arterioles greatest drop. The total cross-sectional area of the capillaries is quite large, and they contribute to relatively minimal drop in pressure. So capillaries is minimal. The larger diameter and relative elasticity of venules and veins ensures that their contribution to the pressure gradient is negligible. So veins and venules is negligible. Arterioles drop, but capillaries are minimal. That's it. Or do I go into the question?
No, that's good for right now. So the your thought process going through everything sounded great. I would say that there are a couple of areas where you're probably losing some time. For example, going through the first paragraph was actually really good. You did a great job kind of breaking that down and identifying what was important and what was significant. Right here, you read this whole equation,
It
but
was
the
right there.
equation is already right here.
Yeah, I noticed that in the beginning. I was like plus 1/3, and when I paused, I realized it was right there. But I was like, oh, I should probably still read it.
Yeah. So outside of that, though, I think that you would have been golden.
Okay.
Um, yeah. Let's see. Yeah. No, I think that's good. Um. So then let's talk. What's the point of this passage?
It says to consider the different types of pressure gradients in vessels.
Okay. So what equations are you going to be thinking about? Obviously, there's this big equation right here, but what else might be coming up?
Density,
Okay.
Because he gave us the density thing. I don't remember. I'm getting frustrated. I don't remember, but I know it has something to do with the fact that I remember when we was going over fluids. We talked about like the flow of fluids and how like when the um cross sectional area or like the
Yep.
where it gets smaller, it goes faster. And we talked about plaque and stuff like that. Whatever we talked about there is another equation.
It sure is. And you brought up two of the variables. So that equation is Q equals AV.
What is that? The flow rate of fluids, area over volume.
It's cross-sectional area times velocity.
Oh wow, I did brought up the what's it called?
Yeah, you brought up the flow, or you brought up the speed of the fluid. Yeah, you did. Um, okay, excellent. So we can be talking about flow rate. We can talk about we're going to be talking about pressures. Um, it gave us a model of the circulatory system that they might reference, but we don't have to worry about it right now. I liked how you didn't really go through the figure too much. You just said it's the circulatory system moving on. That's fine, fantastic. Because when it comes to figures, a lot of the time we waste time going over figures too much. Um, so my recommendation here is to that you don't spend the time reading like an entire equation once you've already kind of gone through what it says in a paragraph.
Mm-hmm.
I like that you did not reread anything, but you broke everything down and you explained it in your own words, kind of what was going on. And in the future as well, continue to kind of skip over big figures like this that don't have a lot of substance at the moment until a question refers to it. And when we approach other passages that have different figures with like more explanation and maybe like a um some axes and everything, then at that point we'll talk about how to kind of approach those. Okay. No, I like this. So moving through here, we're thinking, okay, we're talking flow rate, we're talking fluid dynamic physics. Let's move on to these questions and kind of see how do we break these down. Now, my rule with questions is pretty simple. I like to read the question slowly, right? Like breaking it down bit by bit to see kind of what the question is asking, get a good idea for what the point of the question is, and then trying to see what kind of answers can I preemptively get right now, and then working through the answer choices one by one. Does this fit the answer I was coming up with, or otherwise does this satisfy the question? Um, For example, you would read through this question and then see, okay, well, um, uh, well, I guess what is the question asking? It's asking X, Y, or Z. Sweet. Now, um, I would probably approach it this way, and then looking at answer choice A, does that answer the question? Does that fit my paradigm? Yes or no? And then B, same thing. My recommendation is instead of choosing A, B, C, or D and having those be your four answer choices, look at it as A versus B. Which one do you prefer? Which one do you think is correct out of those two, or which one is more correct? And then you rule out the one that you don't like, and then now we compare B with C.
Yeah,
And
the way
then
they taught me.
okay, perfect, perfect. But the idea is that you're always looking at two answer choices, not more than that. It helps
Okay.
tremendously with kind of thought process and ruling things out. Um, so what I want you to do is go through question one here, read it out loud, walk me through it, discuss with me what your thought process is with it, and then how are we going to go through the answer choices? What do you think the correct answer would be? Okay.
Okay. Assuming that pressure remains consistent, remains constant, which of the following would lead to the greatest increase in bulk flow rate Q throughout systemic circulation? Because it's like pressure is constant, what would increase the flow rate? A lot of things can increase the flow rate because because pressure is the same, probably like the what increase decrease in volume or
So in this case, what I'd be thinking of is, like you said, there's a lot of things that can change flow rate.
Mhm.
Is there a formula that you remember that relates flow rate to pressure?
Mm, it's pressure. P equals what, M over V or something like that?
Um, you said P
Mass?
equals what?
Mass over volume? Pressure is, what's pressure? How many P equations are there?
So for
Oh,
flow rate, and you mentioned this, I think the last time we met, there's a law called Poisson, I don't know, I don't speak French. Poisson's law.
mm-hmm.
And Poisson's law states pressure change is equal to 8 times viscosity times length times flow rate
Or
divided by
2 pi r or something like that.
close
Pi
pi r
r
to the
squared.
fourth.
Um,
This is one of those equations where mostly all you really need to know is this guy right here is on the bottom and it is exponential. The MCAT really wants people to memorize this kind of stuff, but most of the time you'd be okay with knowing that radius is on the bottom and it's exponential. Um, so here we have pressure and we have flow rate. So if we know that pressure is constant and we have a flow rate, we can look at all of these other options to kind of see how is that going to change our flow rate.
okay.
This is what I like to do with these kinds of situations is think, okay, there's a lot, there might be a lot of equations that relate to this kind of stuff, but which equation relates the two variables I'm dealing with? So when I first read through this, I was like, okay, well, Q equals a V. Sure, but that doesn't really relate to pressure directly. Well, there's pressure equation, which says F e or P equals F over A. That could move, pressure over into where that A is. So then that could give us a little bit of information about pressure and flow rate. But then looking through the answer choices, we get viscosity, radius, area, and length. So the area would be able to affect this equation right here, but the other three answer choices wouldn't. So then I'm going to need to think about another equation or something that would be helpful. And that's where I would think, okay, back to Poisson's law. There we go. And I kind of remembered Poisson's law mostly because when I saw vessel radii, I thought, oh shoot, okay, that's that radius that's exponential. So if I increase my radius, that's gonna probably decrease my flow rate. And then I had to kind of bring out where are all the other variables. And I just remembered that pi r is on the bottom, everything else is gonna be on top. So I want you to walk me through the answer choices, starting with A walk me through does A satisfy the answer? Does it fit? Does it fit? And then move on comparing it to B and so on and so forth. Y'all good?
Mm-hmm. Trying to remember what viscosity was. Like the flow, something about the flow of fluid, something about resistance or something.
Okay.
So quartering fluid viscosity versus doubling blood vessel radii, because radius has more to do with the comparison between Q and what's it call it? I'll pick B over A. Yes. No.
So you said you would pick B over A.
Mm-hmm.
So what happens when you double the blood vessel radius?
Um, when you double that, what it halves it.
If you double this radius, it's going to decrease your
Uh,
Q.
and we're trying to increase it.
Yeah.
So to the fourth doesn't matter, right?
Oh, not no. In this case, no. Most of the time, you can just say like if it said something like doubling the blood vessel radii versus and we're I don't know if we're asking more for actual values, then yeah, doubling the exponent would actually matter. But right now we're just talking about a general
Overview.
increase. Uh-huh.
Okay. So we're choosing A over B because doubling will decrease the Q.
Yep, increasing the denominator will decrease the numerator.
Mhm. Doubling the blood vessels cross sectional area. That would
What equation would you use for that one?
Q equals A over V or
Q equals A times V. Exactly. So if I doubled A, what's going to happen to Q?
it's gonna double.
It's going to double. Exactly. They're directly related. So that would absolutely increase A, right?
Hmm. But
What you thinking?
what does that have to do with the relation to the constant pressure?
That's a great question. It doesn't really have much of a relationship as is, but remember that the cross-sectional area does have a relationship to pressure. If you have an increase in cross-sectional area, your pressure would decrease, and therefore, so you could say that this equation is actually saying something more like, let's see, A equals F over P. Um, you could rearrange that all kinds of ways, but I think the point here is that in this system, doubling your cross-sectional area probably could double your flow rate. Except typically what would happen here is if you doubled your cross-sectional area, your flow rate stays constant, but your velocity would halve.
Uh-huh. Uh-huh.
So for the sake of answering this question, I think doubling cross-sectional area, you could say, sure, it could double your flow rate, but it's more likely that your velocity would decrease by a factor of two. We could uh, I would probably be looking at a different answer choice, so
Huh. Different answer choice than C is what you're trying to say?
that's what I'm trying to say.
Okay, so now we're looking into D, doubling the length. Um, yes, yes, yes. Doubling the length. Because the length is on the numerator. If you increase the numerator, all will be good in the world with the Q rate, the flow rate.
So you're saying if I double this right here, that our Q, what's gonna happen to our to the Q?
I don't know. The sum of it will be doubled.
If I double length alone,
Mm-hmm.
Q, you're saying
Would
Q will be doubled?
no would decrease.
It would decrease, it would be halved.
Oh my
Does that make
goodness.
sense?
Yes.
Okay.
So help me understand,
What's up?
why is C wrong again?
So looking at the this equation right here, Q equals AV.
Mm-hmm. It has nothing to do with pressure. That's why we're not looking at it.
Well, not necessarily. Not necessarily. Um, with Q equals AV, does from what you remember, does flow rate change when when you increase or sorry, when you does flow rate typically change when you change cross-sectional area?
No.
No, typically when you change cross-sectional area, your velocity will change instead. So it's not necessarily that C is wrong, it's just not the best answer here.
Answer.
Let's look back at A.
We're quartering, so that means to the fourth power or just adding a four, like to like multiplying by four.
It means that we're multiplying by 1/4.
Okay. Quartering fluid viscosity. So what? We're decreasing the resistance of flow. So that means that would increase the rate of flow. Viscosity is in the equation.
Viscosity is in the equation, yeah.
Is it that B thing at the top?
Uh, it is mu.
Oh, mu. Okay, okay. I didn't
So
know that. Oh, so
so
making that a
so
fourth.
I forgot about that too. But
Okay.
what I saw here was, all right, we're dealing with I know that we're gonna have Poiseuille's law because we have the radii here and the length here. Um, I don't remember what the mu is, but I know that B is wrong. I know that D is wrong. I know that C is unlikely. And if viscosity is in fact this mu character, then if you quarter that, so you take mu divided by 4, that's going to be the same thing. You would have to multiply your flow rate by 4.
Mm-hmm.
So
So that
even if we consider this answer choice C
mm-hmm,
as doubling, answer choice A
that's better.
would quadruple.
Oh, goodness. Okay, so you know how we looked at that question based off of that equation?
Hmm.
I'm not remembering that equation during the exam.
So that would go back to keeping an equation sheet and writing an equation sheet, compiling an equation sheet, and continuously rewriting that equation sheet. So what my for that, my recommendation is to um make an equation sheet on like a piece of paper,
Mm,
organize it by where on the paper everything is going to be related. So an
mhm,
example is like if I have like my sheet right here, I would put like fluid stuff all together in one area. I would put force in one area. I would put, I don't know, maybe energy right near force and all the energy equations, and then so on and so forth. Um, and then rewrite that every week. Try to do it from memory as much as you can, and then fill in the blanks with what you can't remember. But put everything in the same location on your paper. So that on test day, if you need it, you can write everything identically on your scratch paper. But by that time, you very well might just have it all memorized and not even need to write it down.
I love your confidence. Okay, sounds good.
But also, you can think about this like when you were going through this, you remembered the equation Q equals A and V. You remembered that A and V were involved. You did say A over V, but remember that is just A times V. Um, with with that, you could be okay. You could be saying, all right, well, I know that Q equals AV, V is velocity, A is the cross-sectional area. That would help me answer or with answer choice C, but that doesn't help me with A, B, and D. Do I know anything that has to do with any of those? Um, and at that point, you would probably need to have Poiseuille's law. If you didn't, yeah, I don't think you'd be able to answer this. But for what if you've been writing out your equation sheet by that time, then it might be a little bit easier to kind of recall, all right, this this does relate back to an answer choice I had. Or not an answer choice, an equation I had. Okay. So writing out an equation sheet, I'm gonna add this to your calendar as well, or to your schedule as well. At the end of each week, rewrite your equation sheet.
Okay, what is this?
Hey, you ready to move on to question two?
Hmm.
Let's do it. All right, walk me through question two now.
A man has a heart rate and stroke volume of 60 beats per minute and 60 milliliters per beat. His systolic pressure diaspecture are 120 over 80 mmHg, respectively, for this man. Which of the following is approximately systemic vascular resistance? SVR. What's that?
SVR. All right, what would you do for this question?
like the CO times something, something.
Yeah, so you can go down to this equation.
Cardiac output times SVR. What is the SVR? So I got the map, which is the mean arterial pressure, which is what 120 over 80. What is the stroke volume stuff? 60 beats per minute. And
That is a good question. What is the stroke volume stuff talking about?
60 millimeters per beat. What am I getting with that?
So do you remember when we were talking about Q equals AV the other day, and we brought
Mm-hmm.
up the concept of um cardiac output?
Mm-hmm.
Cardiac output was equal to what? Salud.
I don't remember, but I think it was like SV times cardiac output equals to SV times AV or
You're very close. Yeah, SV times heart rate.
heart rate. Okay.
Heart rate times stroke volume equals cardiac output.
The heart rate is the 60 beats per minute.
It sure is, yeah. So we have 60 beats per minute. And then what's stroke volume?
60 milliliters per beat, I guess.
So what's cardiac output?
120. Am I doing that right? No.
No.
1200. 1200. I gotta add another O.
We're
Oh,
multiplying,
6
right?
times 6, 3600. Sorry.
3,600. No, you're good. Nah, it's early. You're good. Um, um, so yeah, 3,600 is our cardiac output. So now what are we doing with the rest of this?
Our map is what 120 over 80.
So what I would do here is I'm trying to figure out, so I have my cardiac output now. I'm trying to find SVR
Mm-hmm.
and all they haven't given me my map necessarily, but
Mm-hmm.
they have given me systolic
Mm-hmm.
and diastolic.
Mm-hmm.
So I can calculate my map and then work through there.
Oh, so I have to do that whole equation.
Yep.
Oh wow.
Well, it's not too shabby, you know. So what's our diastolic pressure?
120. 120.
Is that is that diastolic or systolic?
Systolic pressure. Oh. Oh, okay. Yeah. Diastolic is 80.
Okay. So then we have 80
120 minus 80.
plus 1/3 of 120 minus 80, which is what's 120
Mm,
minus 80?
40.
40. So 80 plus 1/3 of 40. What is 1/3 of 40?
I don't know.
What would it roughly be?
Mm, 1/3 times 40 would be
How many times does 3 go into
going
40?
to 40. Um, what makes 36? 12, no, wait.
What I like to do for this one is say like, all right, so um 3 times 10 is 30, right? So I
Mhm.
know that it's at least 10.
At
And
least
then I go,
12.
okay, sweet, at least 12 because that's 36. And then
And
can you put one
then
more three in there?
13,
13 gives us
9, 39.
39. Sweet. So what I would say is that this is basically 80 plus 13, which is
Mm-hmm. 93.
93. Exactly. So now we're dealing with 93 is our map, and that equals 3,600 times SVR. What's the next step?
Dividing.
Dividing. So what is 93 divided by 3,600? No calculators.
Um, you'd use what, 3?
I'm sorry?
You use 3 to like divide it out. So what it would be uh, to simplify it, you use 3 to simplify is what I'm saying.
I guess I don't know what you mean by using three to simplify.
Like you put 93 over 3,600 and to simplify the other one
Oh,
would
oh, oh.
be
So like
3.
saying 3.6 times 10 to the what something power?
No. I'm saying like we're dividing 93 by 3 and dividing 360 by 300, 3,600 by 3 to simplify the fraction. Or no?
Oh, I see what you're saying. I probably wouldn't go that route. What I would do here is I would put it into scientific notation. So I would say 93 divided by 36 is a lot easier to work with. And this would be 36 times 10 to what power?
There's 2.
Yep, times 10 to the 2. So then how many times does 36 go into 93?
Oh, oh. Well, I will just look at what 36 times what 2 does, right?
That's a good start, yeah.
Okay. 2, 72.
Okay, makes 72.
Mm-hmm.
And then how much is left over from that?
Oh, hold on. 21?
Uh-huh. Yeah, so there's 21 left over, and
Mm-hmm.
21 isn't quite enough to make us get to 3. So we know that this is going to be 2 point something.
Mm-hmm.
About what percentage would you say it is? Like, so 21 is about how much percentage of 36?
Like how much percentage of 21 makes up 36?
Yeah,
Like,
exactly.
is it like, does it cover like 50% or like 75% type
Yeah,
question?
yeah, exactly.
Oh, okay. Wait, 21, would it be, I guess like what, 30, half of that is 15, so it's 21. I'd say half ish, so
Okay,
50%. You can go with
sweet.
50.
So about 50%. Yeah, I'd say pretty close. I'd say so we're looking at roughly that. Now we divided by an exponent. So what happens to our exponent here?
Just goes to O. 1. Oh.
Well, let's think about this. So we
Oh,
divided by 10
we're
squared.
bringing the exponent up, so it's going to turn into a negative from like the
Exactly.
denominator to the numerator. Yeah, yeah.
Exactly. Exactly. All right. So now we're left with 2.5 times 10 to the negative 2. What would your
Mhm.
answer be?
A.
A.
So
I agree.
I'd move my decimal up again. And that would make it to negative one, two. Oh, okay. Okay.
Does that make
Okay.
sense what we did here? So this
Yeah,
question was
but
asked.
like
Go ahead.
I understand, but we're doing a lot
Yeah, we're doing a ton. Um,
for a test.
in reality, all we did,
What?
let me show you real fast. All we did was say, um, we need to figure out what is cardiac output, and we know that that's heart rate times stroke volume. So we just took 60 and 60 and made 3,600.
Mm-hmm.
And that should come, you should be able to get that super quickly.
Mm-hmm.
60 and 60, 3,600. Think about it. That's a very common multiplication, very common problem to use because that's time. If you multiply 60 seconds by 60 minutes, you get 3,600 seconds in 1 hour.
Uh-huh.
So 60 and 60, very common. So 3,600. And then we're looking at our um literally just this guy right here, and then setting that equal to our cardiac output times stroke systemic vascular resistance. And then we calculate all that. We end up with getting our 93 divided by 3,600. You immediately should be saying that that is 93 divided by 36 times 10 to the negative 2. Sorry, 10 to the 2. And then 93 divided by 36. We know that's 36 times 2 is 72. So then we have 2 and some change. And then 21 divided by um, 36 is roughly a little less than two-thirds. So I would say that this is like 2.6 times 10 to the negative 2. So your maths should be very quick here. Always convert things into their scientific notation. That will help tremendously in these situations. Um, and uh, and it helps to go through it more quickly. This question was basically just asking you, do you know what cardiac output is equal to? Do you know if that it's equal to heart rate times stroke volume? If you know that, it's literally a plug and chug. Um, you're as you practice going through these kinds of equations and maths, you'll get a lot faster with it. I will say you are actually tremendously um proficient with maths for the MCAT. I am very impressed with that. You're able to get through them. You just don't have a lot of confidence with it. Like for example, when we went up here with the exponent, and you were like, I don't really know, but then you go, oh well, no, yeah, you just brought it up, so you make it negative. Yeah, you know your maths. You just don't have the confidence right now. So I think you need to improve that confidence just by continuously practicing the mathematics for this test. Okay. Um, for the sake of time right now. I'm gonna stop right here. If you want, so this is a passage found in the on the Jack Weston website. If you go to let's let's end test. Ah, ah. Okay. So if you go into the Jack Weston website, like,
Uh-huh.
and then you just go to sections right here, fundamental passages,
Uh-huh.
physics. This is blood pressure regulation. If you want to continue going through it and finishing up the questions on there, you're more than welcome to. But for the sake of time, I'm gonna stop here for right now. Um, I really do think that the way you went through the passage initially was awesome. The way that you went through the questions, I think needs a little bit of tweaking. I would recommend that you really practice the equation sheet. Start today. I would recommend that you write out an equation sheet. If you want to look one up, you're more than welcome to look one up, but then
Uh-huh.
add to it as you continuously go through more material and get more equations. And then rewrite it every week. And I added this to your schedule as well.
Yeah,
on
I
Saturdays.
got one that I used last year, so I'll just like tweak it today.
Okay, sweet. Um, nice. So, and then continue going through the rest of the physics chapter from the Kaplan book this week. When we meet on Thursday, we can go over some more practice questions as well.
Okay, sounds good. So I'll finish that since it's up. I don't know when I'll finish it, but I'll finish it since it's up. The thing
Sweet.
is that I go on vacation next week.
Oh, that's right. Okay.
So um
That's actually perfect timing because when you go on vacation, that's when I start my rotation. So I'll be able to get an idea for what my hours will be. And the
so we
following
just
week,
won't meet. We just won't meet that week. I'll just chill. So
yeah,
do
I
you
think that,
still want to meet this Thursday though?
absolutely.
Okay, okay. So we'll meet
Yeah,
this Thursday.
I still want to meet this Thursday, and that'll be a good time. We can take some time to also kind of discuss what to do when you're on vacation. I don't recommend that you take the entire vacation off of MCAT prep. I don't
Oh
think
no, I
that
don't plan on doing that.
And I don't think you necessarily need to be going as hard as you've been going. At the very least, I think that it would be helpful to at least do some cars passages and practice that.
Oh
Um,
yay, I haven't done cars. Okay. I used to have like a
okay,
schedule where I wake up, do cars,
so
answer questions.
start doing that. Start
Wake
doing
up, do cars.
yeah, like
One
there's a
passage.
daily Jack Weston's cars passage every day.
Yeah.
I
So
would
wake
say,
up, do a
yeah,
daily cars. Jack Weston passage. Wake up, do
exactly,
cars.
exactly.
My AMC expires in February, I think.
Okay.
My one
Um,
year.
ideally, hopefully, we'll be able to uh to get through that. Worst case scenario, we can get access to in a double MC account that you could be able to use.
Okay.
Um, but we will play that by ear, okay?
All right, sounds good. So daily cars passages is what it's looking like. Okay. All right. So equation sheet, study, and yeah, got it.
All right. All right. Any questions for me today?
Also,
What's up?
responsibilities. November is like a hard month. Not only do we have Thanksgiving, I have two events that I've just been put in charge of planning. I'm trying to relinquish my youth director role to others
Okay.
for one event on the 16th, November 16th.
Yeah.
But then there's a bigger role that I have for planning a baby shower for my goddaughter on the 23rd. Now, before I go too deep into any of these things, should I explain to them that I need to remove myself from the situation?
Um, so that would depend on entirely on how much time it would take to do do those two events. If anything, I would say that the planning for your goddaughter probably would take precedent, would be much more important than the other event.
Yeah, that's when I'm relinquishing the role to, because I'm a youth director,
Hmm.
but I told them that I could only be a youth director for a year because of the responsibilities that I have.
Yeah. Yeah, yeah.
And that year is coming up. So I've expressed to them that this event is them taking over, like the youth takes over the youth. So I've
Yeah, yeah.
already got them started with figuring out how to plan the event. So I wouldn't be too much on that event.
Okay, sweet. So if
So
that's the case, then
that's what I've put in place.
if that's the case, that should be fine then. And we can adjust. We can adjust as well. As we get closer to that time frame, we can talk about how scheduling might be able, how we can approach our scheduling. Okay.
Oh, sounds good. And then one more thing. On Tuesday, I
Hmm.
plan on going on a hike. So what
Tomorrow,
do
Tuesday.
yes. How do you want my studying to look like then?
Um, how long is the hike?
I have no idea, but I think we're gonna be 2 hours out there.
Oh, okay. Uh, you might have to
Wake
switch
up.
out. Well, I would say switch out the day that you would typically take as like a lighter day.
Mm-hmm. and put
and
in work
and
that day,
exactly.
or wake up earlier that day to put in 2 hours.
You could do that too. I'm one of those
Okay.
people who prefers sleep. But you could absolutely do that.
I do. I don't mind waking up. It's just that I don't know what it is. I haven't been waking up this week. I mean, I haven't been waking up last week, and I didn't even work out this morning. Oh,
Okay.
okay,
Any other questions for me?
that's all.
All right. Well, if there's anything else that comes up, please, 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 please reach out. Otherwise, I will see you Thursday morning. Okay.
All right. Thank you.
All right. Have a lovely day.
You too. Bye bye.